to be moderating rather, to be moderating this today's webinar. And thank you everyone for attending. So the title of the webinar, as you will have seen, is Science Communication and AI, which is big title and quite a broad title, but because it is, in fact, a very broad subject, a very broad topic, and there's no way we're going to cover everything in the 40 minutes that we have now. But hopefully it will be a good starting point for reflection and for discussions and for you to follow up then with the speakers today, who I am sure will do a great job of sparking your thinking. So we have with us Mike Schäfer, Professor Mike Schäfer from the University of Zurich. So Mike leads the Science Communication Group at the Institute of Media and Communication and Media Studies. I don't never remember the order. So I'm sure that we all, many of you will know Mike. He's been involved with PCST for a long time, and he is one of the, I would say, leading researchers in science communication, and especially now in the field of looking into AI in science communication and the different aspects. You know, how we use it, how we as science communicators use AI, how journalists use it, how the public uses it, and how it influences how the public think about science. So he's going to be telling us a little bit about that from the research perspective, based on the research that he's involved in. And then we will hear from Mohamed Elsonbaty Ramadan, who I think many of you will also know. Mohamed was vice president of PCST a few years ago. And Mohamed is a journalist and communicator. He is the co-founder of the Arab Forum of Science, Media and Communication, and they've just held a very successful symposium in February. So that was exciting. And Mohamed is a science, he trains in science communication and specifically now also in AI for science communication. So he will tell us more about AI, science communication, training science communicators in using AI from a practical practitioner's perspective. And I will go quiet now and I will hand over to Mike.
Yes, good morning or afternoon or whatever time it is where you are currently. Good to see you. Honored to be here. I'll try to share my screen. I have a couple of slides prepared for the next 15 minutes. All right, which you should be able to see now, I hope. Otherwise, please protest. I mean, I was supposed to talk about science communication and AI and highlight a couple of research findings on that. And I think the starting point is essentially this slide here, up to essentially this point. I've been showing in a lot of my talks, highlighting that when I talk about science communication, I have a broad understanding of science communication as all communication from and about science, where non-scientists are at least part of the audience. And that's broad and can be many things, as you can see already, right? It's communication from individual scientists, from scientific organizations, on social media, it's science journalism, it's fictional communication about science and science-related topics. It's also events and interpersonal communication. But now AI has entered the fray. And AI will be, or I think actually already is a game changer for science communication. And relatedly, scholars, practitioners, pundits have voiced pronounced fears and hopes in recent years. And many of the hopes and fears are actually related to the subtitle of today's presentation, which is efficiency and responsible use. So many of the hopes actually are related, if you like, implicitly or explicitly to efficiency. AI may help explain complex scientific topics better. It may scale up dialogical formats of science communication. It may increase the modalities you can use in science communication beyond text. It may link directly or interface directly with scientific databases and publications. And if you look at the fears that have been uttered, it's often fears related to responsible use. Often it's about, well, AI can blur the origins of information, the accuracy of information, can undermine trust, it can hallucinate, produce bias or reproduce bias, spread disinformation at scale, or put pressure on professional fields like science journalism and science communicators. And what we do in our research is essentially trying to assess these hopes and fears. In the next few minutes, I wanted to show you a couple of findings that I find interesting and that may help us discuss a couple of aspects when it comes to science communication and AI. And I'll do this in three steps, looking at the production, the presentation, and the consumption of science communication. So let's first look at the production. And when I say that, I mean the actors, the organizations, institutions that actively create and shape and circulate science-related communication, which includes scientists, but also professional communicators in universities and scientific organizations, includes intermediaries such as journalists and content producers on social media. And if we look at this broader landscape, research is very uneven, actually, when it comes to how they use AI in science communication. We know surprisingly little, for example, about how researchers use AI in their public communication. We also don't know that much about how influencers on social media use AI when it comes to science-related content. So I will focus here on two fields or subfields where we actually have a little more evidence. And the first one is organizational communicators, professional science communicators, because that has been fairly well documented in Germany by Justus Henke and colleagues, who has done among about 100 to 150 German universities and their communicators surveys since 2023. And what they show is a rapid diffusion of Gen AI among German university communicators. So what you can see here rising strongly is the use of AI for text generation and translations, where the original use case is actually here, right? And you can see that they have risen very strongly. Over 80% of people actually use AI now for these purposes. But you also see here that a lot of other purposes have grown, essentially, that AI use has diversified, analyzing documents, image generation, transcription, using AI for presentations and designs. That is something between a quarter to almost half of people are actually using by now. And notably, the communicators, if you look at the study further, say, well, the attraction is efficiency. We have actually a lot of concerns about quality and especially about accuracy, but the attraction is efficiency. It saves or it can save time. It can accelerate production. So we use it for media releases, for web news, for social media posts to adapt them to different audiences or different platforms. But notably, what they also say is, well, strategic aspects of communication, like target group analysis, impact measurement, etc., that is not something we do via AI. And the second group that we can look at is science journalists, because there also we have a number of studies. Actually, quite early ones also, because in journalism, AI entered journalistic workflows even before the current wave of generative AI. And we see a similar picture here in terms of selective and guarded use. What I show you here, that comes from a global survey where journalists were asked in 105 news organizations globally. And that found that 82% use Gen AI, but mostly again for things like transcription, translation, summarizing, reformatting existing content for new platforms or specific audiences. So also here, full writing, fact checking remain largely human tasks, and science journalists in specific seem to be cautious about using AI. So the pattern that we see here is that individual adoption exists and moves. And what we also see, if we look closer at these studies, is that individual adoption moves faster than organizational strategy. So often it's the case that communicators, journalists use AI, and that sometimes organizations are experimenting with it. But often, organizationally, they have limited budgets, they don't have clear strategies, and often they have rules that essentially tell them what not to do. So what's forbidden, where can't you use it, but not really, well, what's a good use case? Where can you use it productively and for purposes where it actually makes sense? My second point is presentation. In an age where the science as it is presented by AI is becoming more and more important, and more people are using that and get science-related information through that, there's a couple of questions emerging. And the first one is, well, what understanding of science do these systems actually have? And that's why I wanted to show you a study that we have done, our team, where we used what has been called interviewing machines approach, trying to reverse engineer how different LLMs uh, essentially understand science and science communication, and how they answer certain science-related questions. And what we found is that they have a rather positive, a strongly STEM-oriented, and a fairly positivist understanding of science. So it's often presented like that, as playing a crucial role in advancing our knowledge about the world and improving our lives, positive, as a systematic enterprise that builds and organizes knowledge in the form of testable explanations, predictions, positivist, and as something that uncovers the underlying principles and laws governing the physical, biological, and natural world. Not so much the social world, the natural world. So it's STEM focused. And if you look at also publicly debated science related issues, the answers are substantively robust. Two examples are climate change, where the models state, well, climate change exists, it's man-made, it has it causes significant challenges, or astrology, as it is not recognized as a legitimate science by reputable scientific institutions. Which leads me to my second point here, which is the question of accuracy. How correct are LLMs when they present science? And there's actually quite a bit of research here, mostly from the health field. And what we find there is a fairly clear pattern, which is that on established topics with a strong and established scientific consensus, LLMs perform quite well. In the studies that you see here, for example, they find things like, well, LLMs can correctly identify cancer misinformation with about 97% accuracy, or common myths about Alzheimer's or about vaccination, etc. So when the underlying knowledge base is fairly reliable, and the tech companies providing the models do not tamper with them for ideological reasons, the results are actually quite robust, and the models perform fairly, maybe surprisingly well. But research also shows that for novel and emerging and fast-moving topics, the models are considerably less reliable. In benchmark tools, like Simple QA is one of them, that's designed to test accuracy on factual upcoming questions, essentially, of these models. Accuracy for science-related questions drops considerably. It's about 50% for the best of the models, and it drops considerably further for some of them. So last point, consumption, meaning how citizens use AI for science-related uses and with what consequences. And research here first shows that people use Gen AI tools fairly widely. Again, I could have shown you similar, different studies here. I'll show you one of ours. That's what's called the Science Barometer Switzerland, a regular survey that we do in Switzerland, where we look what the Swiss population thinks about science and where they get their science-related information from. This is about the sources that they say they use for science-related information, and you can see that AI tools such as ChatGPT on a 5-point scale has reached this average of 2.6, which puts it even with video platforms like YouTube and TikTok, or with social networks already. Now, that's 2025. It's still less important than TV and print media, for example, but it's more important than radio and podcasts and instant messengers and museums. And if you look at young people, that's even more pronounced. It's even more important for younger people, together with video platforms, for example. What this use doesn't mean, though, is it does not equal trust. So if you ask for trust, do you trust the content that you get presented there? That doesn't translate simply. So when uptake is increasing, it doesn't necessarily mean that trust is increasing as well. Like the communicators, like the journalists, many citizens use these, or seem to use these tools, fairly pragmatically, while remaining cautious about them. And I want to make another point, which is all these now here are averages, right, across the whole population. But AI use and also the perception and evaluation of AI is not evenly distributed across people. So, same study we have done a few years ago, we have reconstructed 4 population segments in Switzerland that look differently at science and have different attitudes towards science. The science files, the critically interested, the large group of passive supporters, and the skeptics group. And if you look at these groups' AI behavior and attitudes, you see that there's the groups in each of the columns. You have all the 4 groups and the differences between the groups. You see that the science engaged groups, especially the science files, have the highest levels when it comes to general AI use or AI use for science related topics. They have the highest AI literacy, etc., etc. And it goes down, not always linearly, but there's clear differences between the different groups, which means that AI may not simply democratize access to science communication and science related content. It can deepen AI divides and resulting knowledge and attitude gaps also. And maybe last point here, caution. Use with caution and segmented use do not mean that AI has no effects. There's a growing body of research that suggests that AI can be quite persuasive, for example, sometimes even more persuasive than human communicators when it comes to issues that are scientific or science related. That's probably, you've seen that, that's maybe the most widely cited study here, Costello et al. In Science, 1.5 years ago, where they essentially asked people to name a conspiracy theory that they believe in, at least to some degree, and then had them have conversations with ChatGPT and realized that these conversations can reduce belief in the conspiracy theories by about 20% and fairly sustainably, as you can see in the red line, over time. And there's similar studies, but I won't go into that in other fields like climate change, for example. Okay, summing up. AI is already widely used, right? And becoming part of the infrastructure through which science communication is produced and presented and consumed. So the question is not, I think, anymore whether AI is useful. It's for what and under what conditions it's useful and can be used responsibly and effectively. So in a Delphi study that we did together with the WHO, we had an international panel of experts identify guiding principles for the use of AI in public communication. And they came up with these 7 that you see here. I won't go into all of them, but just highlight 3 that I think are fairly topical here. Transparency being one, meaning that people should be able to understand where science-related information comes from and when AI has shaped it. Equity, meaning that AI in science communication should not widen existing gaps in access and understanding and fruitful use across different publics. Human centricity, meaning that AI should support science communication that responds to people's needs and questions and context, not just produce more content. And for that, it needs obviously not just the tools, but standards and discussions and reflections about these standards, like we'll hopefully have here today. That's it for me. Happy to discuss and answer questions. Thank you very much.
Okay. Thank you very much, Mike. That is a lot of food for thought. I think we will, in the interest of time, keep the discussion for the end. But if anyone has a burning question, on a specific question on anything that Mike presented, we can take one question, and then we'll have a wider discussion at the end. Can't see any hands. Okay. Well then, in that case, Mohamed, over to you.
So thank you very much for having me today. I'm glad to see a lot of familiar faces here. So I will share my screen and start directly. Let me know if you cannot see my screen. Okay, perfect. So I'm trying here to focus more on a practitioner perspective through my work in training other science communicators and journalists on using generative AI to communicate science responsibly and effectively. So Anna has already introduced me. My name is Mohamed Elsonbaty, and I use the same bio she has used and fed it into one of the generative AI models and ask it to imagine how I look like. And that was the result. Actually, I could see first, a lot of improvements through different models. The older one was really awful, but this one, I would say it's okay. It managed to capture some of okay, I'm Middle Eastern, I'm in mid-30s, but I don't have a beard or that much hair. But anyway, one thing I wanted to highlight here, because I'm originally from Egypt and my native language is Arabic, so it tried to do something with that, and it put these sticky notes here, and actually it looks like Arabic, but it's gibberish. It's not Arabic at all. And this is one of the very important things I always starting with to highlight when I'm training science communicator and journalists on how to use generative AI, that generative AI is biased. And they need to know why it is biased and where this bias is coming from. So SciComm AIs and kind of initiative try to empower science communicators and journalists through training them in using AI in an effective and responsible way. It was established in November 23, so I think it's 2.5 years right now. And I have worked with like different institutions like universities and also some science communication networks, local and regional and also global, and many media outlets too. Through my work, I find that there are 3 core components that we need to focus on in order to train science communicators to use generative AI both effectively and ethically. Those 3 are first, understanding generative AI. They need to understand how it works, how it was developed, what is its limitations in order to be able to use it in an effective and also responsible way. And then how we can apply generative AI to communicate science, in our work as practitioners, and make sure that when we adopt the use of generative AI in our work, we do this in a responsible way. So these are like the 3 core components. I will go through them like quickly. The first one is understanding AI. They need to understand how it was developed. It was developed based on a huge amount of data. Where is this data coming from? It's coming from the internet. Internet is full of rubbish. Mainly, most of its content in English is not representative enough. Then the machines was trained on these data, and this is where the machine work. And in a later stage, before releasing generative AI models to the public, there was a stage of fine-tuning where humans were testing the model and check its answers. And again, we don't know who are these persons and on what parameters exactly they were evaluating this. Then it was released to the users for free in most of cases. Why? Because users like us keep feeding the model with data and also with fine-tuning, because when you don't like what ChatGPT is doing, you said, okay, this is wrong, do this in that way. So actually, that's why it's free, because we are providing our valuable data and feedback to the models. And okay, this is how it was developed, but how it works, in a simple term, generative AI is a fancy autocomplete. It's just a statistical model that statistically predicting the next word to generate text. So when I type, for example, Mary had, it knows that Mary had a little lamp, not anything else, because most of the data it was trained on say that statistically speaking, the next word when you type Mary had will be a little lamp. And based on the huge amount of data, which is really a huge amount of data, for example, the first model of ChatGPT was trained on a data that would take a human person almost 1 million years just to read all of this without doing anything else. So by the end of it, it's a statistical model. Yes, it's a fancy and very complicated one, but it's a statistical model. Also, it carries limitations. Some limitations related to data, because it dependent only on the data it was trained on. So for example, if a certain piece of information was not included in this corpus of data it was trained on, it doesn't know about it. It is biased because the data it was trained on it was already biased, and it's not updated all the time. Now we managed to connect many of the models or almost all of them to the internet, but it's still not like providing real-time information. There are some other limitations about the output, like variations. If you type the same prompt or the same question to any model, for every single time it will give you a different answer. And it was trained to do that because it was trained to mimic humans, where actually we don't provide the same answer for the same question all the time. And of course, inaccuracies, that a lot of information or many information can be inaccurate, or what we call hallucinations. And of course, there are other concerns like ethical concerns about privacy, environment, the impact of generative AI on economy and society. All of these science communicator and journalists should be aware before using generative AI. So based on all of that, this understanding, I provide a kind of how we should deal with generative AI simply as a superhuman AI intern with some restrictions, because it has vast abilities. It has some restrictions because it has some errors like hallucinations and bias, limited memory. This is something that's like improving with time. But by the end of it, we can think of it as an intern. Why? Because intern can do mistakes, generative AI do mistakes. intern needed training and supervision. This is very important. This we here as practitioners, science communication center practitioners, has to work to train and supervise the work of the AI. And of course, intern work has always to be reviewed, and we need to do that with AI. Another example of bias, when I asked AI to generate an image for the superhuman AI intern, it decided that it will be white, male, muscular, in semi-casual dress, which is okay. Again, show the bias. So now we have known the first core component of understanding AI. The second one is applying generative AI in science communication. And this is where like the practitioners need to learn skills on how they can use it in an effective way. So prompt engineering right now is something considered to be a little bit obsolete because prompt engineering was built to overcome some of the obstacles or like limitations of the old models. So we start with something a little bit advanced called prompt patterns, which comes from computer science research, which is a way, I would say it's an advanced way of prompt engineering on how you can phrase your prompts in a certain way to guarantee the most, I would say, the best output. So we start with this kind of prompt patterns. I mean, there are many. I just focus on these 7 because I think they are very important for science communicators. Then we combine this with some other prompt techniques. So we start with the prompt pattern and prompt techniques, which are different techniques to ensure that we are asking the model in the right way. Because if you don't ask the model in the right way, it will give you a very bad answer. As usually they say, like garbage in equal garbage out. So it depends on what you are typing and or how you ask the model or generative AI to do a certain task for you. After that, I provide a kind of a framework on how you can apply all of this in order to be able to use AI effectively. And this framework is not only about like prompting or writing a good prompt, it's about how the entire process of using generative AI to do a science communication task. So this framework is called ComSci AI, which stands for context. We start with context because now people are moving from prompt engineering to context engineering. And whenever you provide more context to the model, the better answers you will get. And we provide it also with the overall final objective. This is for the O. The M is for mindset. It's our mindset as users thinking of AI as a superhuman AI intern. And we keep that in mind. And then I use my experience as a science communicator or a journalist to provide first as tips of how we can do this task or the overall objective. Then C for combining patterns and chained prompting. So I use the patterns we have talked about briefly before and make sure that I go through a conversation with AI. It's not about just writing a very good 500 word long prompt and that's it. No, I have to keep the conversation. I need to provide it with input and information whenever needed. And finally, the AI stands for always review. I remember from my mindset, it's an intern. Any output coming from the AI has always to be reviewed. And finally, I need to iterate and improve because it's a kind of an ongoing process. I iterate and improve the output and also improve my way of working and dealing with AI. And this comes with time. So through this kind of framework, we can do a kind of a very complicated science communication task in less time. How much time does it save? It depends on your skill in using the AI. And also it depends on how much quality do you want to get out from this kind of model. So this is for the second component of using AI in an effective way. And finally, the third component is how to adopt generative AI responsibly. And this is very important. And from my experience, I would say I noticed that whenever I train science journalists or communicators on using AI, I found them skeptic, which a very healthy thing. I always say, if you are skeptic about using generative AI, I can assure you that you will try your best to use it or adopt it responsibly. But rather than providing answers, because I don't think there is a kind of a clear answers on how this should be achieved, I provide a lot of questions about bias. From our understanding of AI, AI has a very big bias problem. I can give you an example that I always like to do, that I ask any kind of model, give me names of 10 scientists who has made great contributions to science. And the first answers in most of cases will be 10 white males from the 20th century. And when I ask it, okay, this is not diverse enough. So it started to put some name of females, but again, all from Western countries. And then I asked, okay, I need like more diverse. And then it started to put some names come from people coming from Middle East or coming from China or other parts of the world. But the notable thing that all of the scientists were suggested actually were dual nationals of these countries and other Western countries. So these make me always worries about the bias when we are trying to communicate science, because when we ask, for example, ChatGPT to communicate or try to communicate or explain a certain piece of information for an 8 years old child from Egypt, it has its own assumptions or perspective on that, which is not necessarily true. The second one is verification, that of course, again, we need to verify every single piece of information the AI is telling us. Transparency is a big issue. To what extent should I be transparent if I use generative AI in my work? Because some people would say, okay, it's a tool like another tool. I don't say that, okay, I used Google or I used Microsoft Office to do this or that. Should I say that with ChatGPT or not? And one of the other problems is that there is, in many cases, there is no clear policies for organizations on how they can declare that. The fourth one is over-reliance, because whenever you use more generative AI, it happens to you subconsciously that you rely on it more and more, and because also like it's very persuasive, and you start doing like little verification of what produced or just take everything it says for granted. And I noticed this even happened to me, that sometimes I have to stop and think, no, I just over relied on it because I just keep believing whatever it says to me, I need to be sure. Another thing about privacy, if you are communicating something that includes private information, the information you are sharing with the model, do you have the right to share this data or not? The legal framework, which could be like very complicated because it differs from country to country. And for example, in Europe, the rules are more strict compared to other parts in the world. In some places, the legal framework doesn't even exist. It's far behind the progress or the development of the technology itself. And also, you need to think what is legal versus what is moral or ethical. This is another question that should be thought. And finally, the environmental impact of using AI. And there are like several arguments within this. I prefer to maybe discuss it later during the question time. So these are the main three components that I usually use in order to train science communications and journalists to use AI in their work in an effective and responsible way. There are some resources I can share with you in the chat about a research paper for these prompt patterns I was speaking about. For book lovers, I would recommend this book, Co-Intelligence by Ethan Mollick, because it just like goes through the entire ecosystem of AI, provide you a very good overview of how it works and how it should be used. If you want to do some self-learning, Coursera, if you just type generative AI, there is like a lot of things that you can learn. Almost all of what I have learned is coming from the internet, coming through self-learning. And finally, you can like visit our my website for the initiative SciComm AI and know more about that, or just contact me. So thank you, and looking forward for your questions.
Thank you very much, Mo. That was very interesting. I think we're so privileged to have the research perspective and the practitioner's perspective. So I will open up to questions. I know I have several, but I will give it to the floor. Oh, Giulia Rizzo. Go
Yes,
ahead.
hi from Italy to everyone. Hi. I have a question both for Mike and Mohamed, I guess, because I was wondering if there is experience or data about over-prompting. For example, to write too complex prompts or with too much information so that the output isn't I don't know, it not fits what do you want, or it's overcomplicated. Is there some experience about that?
Not that I know is the short answer. But I'm sure there is. Because the whole prompting literature is very, very broad and it goes way beyond science communication, of course. I think what Mohamed also said and what is important is that this needs to be understood as an iterative process, and many people use it like that also. So you do it again, right? And that's one of the actual strengths of the tools, that you can say, well, look, I really didn't get. Can you simplify, or can you give me an example? I really don't see how this can be. And this is something that's new. So uh, that needs to be taken into account. And the whole prompting thing, of course, also is changing, right? It's we have this now, we do this now text-based or use dictation or whatever. That's gonna look very different in fairly short time, I would assume.
Yeah,
Mohammed?
I just want to add to this that I mean, I would say like if you asked me this question like 3 months ago, I would say no, you need to. I mean, the longer the prompt is, the better the output will be. But now with the new models, that thinking model or reasoning, actually what it's doing is when you ask it for a certain prompt, it try to follow some of the patterns I was speaking about. Like for example, rather than just do the task, try to ask itself or ask you as a user for more questions or information needed to do that. So I would say yes, we will write shorter prompts or maybe in a different way. But in the same time, the more information or contextual information you provide to it, the better the results you get. Like, for example, if you ask it to write a press release about this research paper and you just give a research paper, it will do, I would say, below the average job. But if you provide like more contextual information, like I am a communication officer working for this organization or this university, because of course a press release issued from the university would be different with if it was issued by the journal, for example. So this kind of contextual information you provide it gives you a better answer. Now we have this kind of projects in code projects function where actually you can upload certain documents and the model keep it in its memory as long as you are working in these projects. That was not there before. So it is changing for the sake of shorter prompts, but still you need to provide it more and more information.
Thank you.
Thank you. Thanks. Alexandra?
Thank you very much for your talks. I will make a question that you probably heard already dozens of times, but it's really, I will not say easy, but it's a clear pattern how you teach people of our age how to use AI responsibly, because we built on the competencies that we got in pre-AI era. So I can do checking, I can do all these things because I am an old person. How you think is the future when we have people born and studied in AI era? Will they be able to use AI responsibly and do all that human control that we do, even if they are brought up in the AI-dominated environment?
That's a very good question. All right. I don't know who wants to go first. Mike.
Yeah, sure. I mean, that's one of the core questions, right? Right now, does it change patterns of use essentially and related competencies that people just don't develop now from the start? A certain critical literacy when you're approaching AI models, etc. Apart from the long-term effects that it has. And it's something to worry about to a degree, and the answers are not that easy and straightforward. It's the same answers we had with other problematic issues when it comes to tech environment or digital environments, which is usually the triad between regulation, individual competence, and the respective training and education in schools, etc., that all has to result in this kind of competence. And then the third is usually the responsibility of the tech platforms. And the responsibility of the tech platforms, at least of the ones that are currently use. I wouldn't bet on that much currently, and that may change, but it's lock-in effect. It's all we've all seen the debates about it's essentially often the LLMs that we are using are the LLMs of the big tech platforms to begin with, and it's difficult to change the trajectory there. Competencies are one way of doing it, yes, but it takes time. It's not that easy. It's not even that easy to define exactly how that would look like. If you say, okay, my 8-year-old kid, what should he or she learn in school? It can't be so specific that it's not useful in 6 months anymore or in 2 years anymore. So it has to be some kind of generalized skill, which is difficult then because it has to contain an assessment of what it is. It's not that easy, but that's certainly an important part of the picture. And then regulation has to come in there as well. Again, difficult. It's global, it's transnational models, difficult to regulate. We had the whole discussion about social media. That's very similar in that respect, at least when it comes to AI, and there's some movement there as we've seen now, but difficult. But it's a very, very important question, yes.
You have a question from Yale?
Hi, everyone. And thank you very much for this very fascinating, very timely webinar. And I want to maybe continue Alexandra's great question, but I want to take it from a little bit of a different perspective. And I was wondering how we can navigate or mitigate actually some sort of a halo effect that we recently started to see in both scientists, but also in the general public perception of Gen AI generated content. So in one of our recent studies that was just published in Science Communication, we saw that when scientists got Gen AI feedback on their own texts, they perceived that as better. Automatically, they perceived that without even, not a lot of reflection or critical reading, the feedback by Gen AI was perceived as the content that was perceived as better. So it's some sort of a bit of a halo effect that when communicating science, Gen AI might be better than me as a scientist in doing that. But on the other hand, we see more and more evidence showing that when people are confronted or presented with Gen AI generated content or polished content, there's a little bit of we see pushback, right? So people don't want that information to be too polished. And I'm trying to think, how can we navigate this, something that seems to be like a gap, and what are the competencies that we need to foster in order to mitigate that or deal with that? Yeah.
Mike, do you want to try this one? I think it's...
I can, but I don't want to. I'm happy to. I mean,
No.
just quickly, two things.
Let's do
One
both.
is, I
Let's do both.
think, almost nowhere in science communication or other kinds of communication for that matter, I would say it's that simple. It's always more nuanced, right? So, I would say, of course, there's context, and there's a lot of studies in the health field, for example, how patients assess feedback from LLMs as compared to actual doctors. And very interesting findings in some degrees, where LLMs can be better. And that is related to things like, well, it's longer, it has more detail, the tone is very empathetic, it's perceived as neutral, or it can be perceived as more neutral than other sources. So it has advantages, but it's not that these advantages count in every context, I would say. So Gen AI is better. I don't think so. It's yes, in some contexts, maybe. For some audiences, for some purposes, it's not better. If I want to, well, I don't know, if I want to raise enthusiasm among 6-year-old kids for science, it's much better if I go there and do experiments with them than if I give them of course. So it depends on LLMs have their strength and weaknesses as well. So I think it has to be looked at nuance. Would be interesting to see. I have to look at the study. It sounds very interesting why the scientists found it so worthy.
Yeah. Mo, would you like to add anything?
No, I think sometimes like we feel that generative AI is doing better than us when we actually fail doing our job. Like for example, the example that Mike has said now that generative AI is more empathetic in communicating with patients. This is because like healthcare staff doesn't do their job in the proper way. So this is one thing. And for the tendency of like for the users that they think that generative AI is providing better answers, I think this is from my like I would say observation. It depends on how much is your experience in that field. So for example, if I'm asking ChatGPT to do something I'm already familiar with, I can spot that it's not okay or it could be better in that way. But if it's something that I have no idea about, I will be impressed for every single piece of information it's given me because like it will be better than the average from what I will get if I'm doing it like in the old way of going through Google and try to find the information myself. So this is where you can see the difference. And I believe like in maybe this will come with time that with more adoption of AI, because it's happening, whether we like it or not, we will find where we will discover this kind of gaps that we need to include this in the AI literacy. We need for this specific kind of audience, maybe this need to be taken into consideration when we are training them. So I think it will require some time. What I'm afraid of during this kind of transition state, what's happening, it can go really bad. Yes, it can go really bad, but what we can do for that? That's another question.
Okay, we are over time, but I do want to take the last two questions from Siddharth and Kelvin. So maybe you can just go ahead with your questions and then we answer them together as well. Sid.
Sure. Thanks, Mike and Mohammed, for the brilliant provocations. I was just wondering, and continuing on your point about the equity angle in terms of who really understands what AI is doing and what kind of skills you need to develop. I think the landscape of AI skills and AI technology seems to be developing and evolving really quick. So I just wanted to ask you, what do you think is sort of like, it's almost like there's another niche of science communication for communicating about AI skills and technology developing. And Mohammed is a perfect example of someone who's doing that, right? So I was just wondering if you have any thoughts on what kind of an ecosystem we need to sort of fill the gaps. And I'm pretty sure it's not just one kind of expert or sort of person being actor we need in the system. So if you had to imagine an ecosystem where we can move towards more AI literacy, more critical AI literacy, what kind of actors would you imagine apart from, say, just science communicators who talk about AI?
Right. Remember that question? We'll go to Kelvin now.
Yeah, I've actually got a question to pose, and I think you made a very valid point about the access to AI, and I'm just wondering to flip it. Is that not the reason why you don't have very diverse AI outputs? For example, I'll give you a very practical example. For example, Claude costs like $200 per annum. Now, I couldn't imagine that somebody in China or somebody in Russia might have necessarily have that sort of access. Is that not one of the reasons why you don't have such diversity in terms of the platforms? Not even talking about the research that takes place in Africa. We recently, so I'm in the TB vaccine research field. And one of the challenges that we're sitting, for example, is that Russia as well as China have got 2 TB vaccines in, well, they say it's phase 3, but there's very little known about it. And are we not perpetuating those sort of divides by the exact AI platforms that we're using, where not everybody is able to access it, and you have this inequity? And so that's the one question that I want to pose, that you've got so many platforms to choose from that it's very difficult. I mean, if you're doing coding, for example, Claude would probably be the best. But if you're just generally pottering around with AI, Copilot is probably still the best platform. Thanks.
Okay, so Mo, shall we start with you? Do you want to either of the questions or both?
Yeah, I think I will, answer Kelvin's question. The second question, because I think the problem is that generative AI depends mainly on this kind of data dependence. So it can always answer from what was trained on, and what was trained on, which we don't know what it was exactly, mostly coming from the internet. So think of all the bias available on the internet, it is there. And the problem for the AI that if it wasn't trained on this data, it doesn't exist for it. This is one big problem. So, for example, if you have a lot of information in a certain language that were in a written format, not in a digital format, it means that the AI will not be aware of this context. And of course, the internet is not representative of the reality. I will take the example of the Arabic language, which is the fifth most spoken language worldwide with more than 1 billion people, but yet the Arabic content on the internet is around 1 to 2%. That's why it's not there, or if you deal with any like big model, it will not do the same for Arabic. And so some countries try to develop in the Arab world, try to build their own AI using training it on more materials coming from books and stuff like that. And I met one of these people who were developing it, and he told me another problem, that in order to train a model on a data, the structure of the model itself was built and designed to deal with English language. So it's not even able to be used to train it on other language with different system like Arabic or like Chinese or Japanese. And this is another limitation from like not from the structure of the algorithm itself, and also from the structure of the hardware of the processors that trying to process this piece of information. So it's this kind it's of problem. It's very, very deep. And while a lot of people think, okay, we can deal with like this kind of problem of hallucination or try to make the models more accurate, but bias, it will exist for a long time. And we don't have a kind of a real solution for that so far.
Hey, Mike, would you like to take Sid's question on the actors that we need?
Yeah, I'll say two things. Quickly on the bias, I think that tackling onto what Mo has said, I think what interests me also, I agree with everything you said. What interests me also is that in certain fields, my climate example from earlier, for example, there are biases included in the actual outputs that we probably like. Skeptical content is very difficult to come by. Climate skepticism is very difficult to come by from AI models across a range of models, actually, including Grok. So the X AI. And that's obviously a decision made by the providers that have it's in the training data. Obviously, there's a lot of skeptical content out there and denialism. It's been trained out. And this step and this decision that introduced, we can discuss if you want to call this bias, but or a correction rather, that is an interesting facet. And currently that's largely done by the tech companies. What's in, what's out, and how so. And that really is a challenge. On Siddharth's question, I'm not sure I got the second one, I have to say. On the first one, I fully agree. The challenging thing, but also research-wise, the interesting thing about AI and science communication is that it's both a channel and an object of science communication and an agent itself. So it's on the one hand, you have communication about AI, and that includes public communication, includes all the training kids, people, raising literacy, etc., to learn about AI as an object of science communication, like we did with many other technologies and objects in science-related fields. And at the same time, it's an agent. At the same time, it's a channel that has, and it's not just a channel, it's a channel that has more agency that channels had before, and more scale and scalability that channels had before. And that is really interesting. And looking at what they are and how they function really is important. I think it's looking also beyond. I mean, we did a lot of work on GPT, but looking beyond GPT, especially if we look at the global south, for example, Kevin's point from earlier, the DeepSeek is different and it has strengths and weaknesses. Again, it's easier to use. It doesn't cost as much. May not be as good as the latest frontier Claude model, but it's actually fairly good. But you can't have a conversation about Tiananmen and other objects, of course, there. So you have to see how these things then work. And as with the social media example or the platform example, if you like, is instructive, I feel, because we are in a situation, we as citizens, we as scientists, we as users, there is no Leviathan that is organizing this field for us. It's transnational technology that's being used all across the world and across the globe. And there is nobody regulating that for us or something like that. It really is a challenging technology to deal with for all the advantages that it has and takes all of us in various ways.
Okay, all right. We could go on for a long time, but we need to wrap up now. I think there are several threads in this conversation that maybe, Alexandra, I'm looking at you, and see that maybe we need to pick up and think of more webinars on this deep dives into the different topics. Thank you very much, Mike. Thank you very much, Mo, for your time and for your such interesting insights and so much food for thought here. And thank you everyone for tuning in. All right. Oh, lots of applause. Yay.
Thanks for sharing. Thank you.
Bye everyone. See you soon.
Thank
Thank
you.
you.
Have a
Just a
great
moment.
day.
Oh,
Wait.
wait, not everyone. No, don't go. Don't go.
Oh,
I
but
meant
we are not. But we are not done.
yes. Sorry. Oops. Don't go.
So we're done with the webinar.
But I think the speakers stay.
Because they are very welcome to stay if they have time. Would be our pleasure, but if you are too busy, we understand that. So we ate a bit of time of the speed dating, but as by tradition, that's okay. I mean, we are not. We don't have the bells or very grumpy timekeeper. But as a tradition already for our webinars this year, we will follow up with a speed dating session where there is no structure. You just come back here, and the Zoom magician Nicoletta will put us in breakout rooms, just being able to meet random people from PCST community